Hello everyone, today I'm going to talk to you about how Vietnam is asking China for electricity and also wants China's power generation technology. In addition, China has become the world's first fully electrified major country with power generation 2.2 times that of the United States. American experts are warning that they're facing power shortages. How are they supposed to develop AI? Developing AI is like feeding a giant beast that devours electricity. Now the whole world is starting to worry about not having enough power, except for China. When the United States tried to choke off China's AI development with chips, it turned out that America's own AI progress was being stifled by a lack of energy. Investment bank Goldman Sachs recently released a 26-page in-depth report titled Power Generation in the Age of AI. It bluntly states that the world is facing an unprecedented power crisis. The report states that the electricity consumption of AI servers and data centers is far outpacing the rate at which power grids are expanding, and that power supply may become the biggest bottleneck in the AI era. Goldman Sachs believes that the key to building the next wave of data centers is not faster chips, but rather more creative ways of providing electricity and related financing solutions. Training a large AI model requires thousands of GPU desktop processors running simultaneously, along with liquid cooling systems, resulting in enormous energy consumption. Goldman Sachs predicts that by 2027, the power consumption of next-generation AI racks will reach 50 times that of cloud racks in 2020. Even with continuous improvements in energy efficiency, by 2030, the global power demand of data centers could still increase by 160% compared to current levels. Goldman Sachs says that an AI facility with a capacity of 250 megawatts could cost as much as $12 billion, with more than half of that spent on GPU desktop processors. This means that AI infrastructure is not only a technological challenge, but also involves a complete overhaul of capital and the entire supply chain, all of which require massive amounts of electricity. However, the average age of transmission facilities in the United States has already exceeded 40 years, and many power plants are outdated and in poor condition, while building new plants is far too slow. It can take as long as 7 years just to get approval to build a new natural gas power plant. Goldman Sachs predicts that in the future, most of the world's new electricity supply will come from gas-fired power plants and renewable energy. Of this, 30 percentage points will come from combined cycle gas, 27.5 percentage points from solar energy, and 12.5 percentage points from wind energy. As for nuclear power and long-duration energy storage, those are considered long-term bets. What Goldman Sachs didn't mention is that the so-called Great Beauty Act proposed by the party has further crippled investment in wind and solar power generation in the US. It's like someone who's already disabled having another leg broken. The US has insufficient power plants and an aging grid. To meet these challenges, there are plans to invest over $700 billion in the power grid by 2030. But Goldman Sachs warns that this is still not enough to make up for the explosive growth in AI energy consumption. Currently, some AI operators are choosing to move away from traditional power grids, building data centers directly next to power plants, or setting up their own micro power plants as a contingency. However, these measures may spark environmental and community controversies, making them difficult to implement. Behind this competition between China and the US lies a contest of power generation capacity. China has now become a major electrified nation. Let's take a look at the development of electricity generation among the world's major countries from 1985 to 2024. China was originally far behind the United States and the European Union. After China joined the WTO in 2001, its electricity generation surged, first surpassing the EU, then overtaking the United States. According to a report by the Energy Institute, in 2024, China's electricity generation reached 1.01 million gigawatt-hours, while the United States generated only 463,000 gigawatt-hours. China's electricity generation is 2.2 times that of the United States, driven by massive industrial electricity consumption and widespread electrification in society, such as the high demand for electricity from electric vehicles and high-speed rail. Not only does China generate more electricity, but its installed capacity is also much greater than that of the United States. By the end of 2024, China's installed power generation capacity had reached 3.35 billion kilowatts, while the United States had only 1.25 billion kilowatts during the same period. China's capacity is about 2.7 times that of the US. According to the latest data from the Global Energy Monitor, China is even further ahead of the United States in new energy, and the global landscape of clean energy is being rewritten at an astonishing pace. The amount of wind and solar power capacity that China adds in just 1 year has already surpassed the total of all renewable energy facilities currently in the United States. The United States was already far behind China in this industrial race, and with President Trump signing this so-called Beautiful Act, it has further cemented America's position as a loser in clean energy. According to a report by CNN, Trump has drastically cut tax credits for wind and solar power. Business leaders have warned that this will drive up electricity costs for both businesses and households because wind and solar power, which used to be the cheaper sources on the grid, are now much harder to develop. According to modeling by the think tank Rhodium Group, compared to previous policy scenarios, new legislation from the Trump administration will cut the projected increase in renewable energy capacity over the next decade by half. As the construction costs for wind and solar power rise, the supply gap will have to be filled by more expensive natural gas power generation. This will lead to a general increase in electricity prices across all states in the US. Meanwhile, China currently has 1,400 gigawatts of new energy generation capacity, which is 5 times the scale of similar facilities in the United States. And China is actively building up to 510 gigawatts of advanced wind and solar power facilities. This will widen the gap with the United States even further. Li Shi, director of the China Climate Center at the Asia Society Policy Institute, bluntly stated that this competition between China and the US is actually already over. Now, many countries rely on China for assistance with electricity supply, and one of them is Vietnam. In the summer of 2023, Vietnam experienced the most severe power shortage in its history. At that time, streetlights in the capital Hanoi went dark, Samsung's factory assembly lines came to a halt, and Foxconn's workshops barely managed to operate using diesel generators. The drought at the time caused one of Vietnam's hydropower plants to nearly shut down, resulting in a nationwide power supply gap of more than 10%. In this critical situation, Vietnamese Deputy Prime Minister Tran Hong Ha made an emergency visit to China and signed a 6-year electricity purchase agreement between China and Vietnam. China supplied electricity to northern Vietnam at the low price of 0.47 yuan per kilowatt hour, which was even lower than the residential electricity price in Guangxi. However, by this February, when Tran Hong Ha visited China again, their request had shifted from buying electricity to sharing technology. He explicitly stated that he hoped China would share core technologies such as ultra-high voltage power transmission and smart grids to help Vietnam achieve energy independence. Vietnam's anxiety stems from structural contradictions. Although its manufacturing industry has taken off and attracted a large amount of foreign investment to build factories after joining the CPTPP free trade agreement, its power infrastructure has seriously lagged behind. The total length of transmission lines nationwide is only 300,000 kilometers, less than half of China's, and the loss rate is as high as 15 percentage points, with hydropower accounting for 29 percentage points. However, the drought in 2023 led to a sharp drop in power generation. Coal power accounts for 32 percentage points, which means expensive coal must be imported from Indonesia. Although Vietnam plans to increase the share of renewable energy to 36% by 2030, even though solar power is being generated, the grid connection rate is less than 40%, and many wind turbines are also sitting idle. What's even more urgent is that in 2024, industrial electricity demand in Vietnam surged by 13%, and the power gap in northern Vietnam reached 2,000 megawatts. Apple's supply chain companies have lost billions of dollars due to frequent power outages, forcing the Vietnamese government to restart nuclear power projects that had been suspended for 8 years. China has taken a rather cautious approach to Vietnam's proposal of exchanging technology for market access. China holds a significant technological advantage in power generation. Its ultra-high voltage transmission is 5 times more efficient than conventional technology, with a loss rate of only 4.8%. More than 80 global standards for ultra-high voltage transmission have been set by China, but transferring core technology involves 3 major risks. First, Vietnam occupies 29 islands and reefs in the South China Sea that belong to China, and at the same time, it is drawing in the US, Japan, and South Korea to participate in its power grid upgrades. In 2024, South Korea and Vietnam signed an energy agreement, and Samsung Electronics plans to invest in helping digitize Vietnam's power grid. Second, Vietnam's manufacturing industry is highly similar to China's. If electricity costs decrease, its textile and electronics OEM industries will directly compete with Chinese companies for orders. Third, State Grid Corporation of China has invested more than 700 billion yuan in the research and development of ultra-high voltage transmission. If these core patents are lost, it could weaken China's dominance in the ASEAN energy market. As a result, a subtle turning point appeared in the joint statement between China and Vietnam this April. China and Vietnam agreed to jointly build a safe and stable industrial and supply chain. For the first time, Vietnam pledged to prioritize adopting Chinese standards to upgrade its power grid. Finally, China Energy Engineering Corporation and Vietnam Electricity Group signed an agreement. The Chinese side will build an 80-megawatt offshore wind farm in Tra Vinh province and share experience in equipment maintenance, but refuse to share design patents. The China-Vietnam interconnection project will require the use of Chinese ultra-high voltage equipment. Vietnam's newly tendered energy storage projects must be compatible with China's energy agreements, while China's export of technology is conditional on Vietnam opening up its rare earth mining rights. Among these, the largest rare earth mine, Dong Pao, has reserves that can meet 20% of China's demand. Vietnam plans to spend $136 billion to upgrade its power system, but in 2024, Vietnam's GDP is only $470 billion. Such a large investment requires foreign capital support. China is gradually exporting its technology to break this situation. In the short term, cross-border power supply will be expanded, providing 1.8 billion kilowatt-hours of electricity to Vietnam annually, with prices maintained at 0.35 to 0.5 yuan per kilowatt-hour, subsidizing the production capacity of Chinese-funded OEM factories in Vietnam. In the medium term, the equipment leasing model will be promoted. For example, Longi Solar's photovoltaic modules will enter Vietnamese textile factories through installment payments, which not only reduces costs for Vietnamese enterprises but also protects China's intellectual property. In the long term, efforts will be made to promote the Langkang Mekong Regional Electricity Trading Platform, coordinating Lao hydropower and Thai photovoltaics through the Chinese power grid before transmitting it to Vietnam, thereby strengthening China's control over regional energy. To sum up, first, Trump wants to rebuild the US as a manufacturing hub, but there are already significant problems with power supply. At the same time, he is aggressively restricting wind and solar energy, which is further worsening the power generation situation in the United States. Second, AI development is extremely power intensive, and the construction of new power plants in the US can't keep up. So while the US wants to use chips to restrict China's AI, it ends up being crippled by its own power shortages. Third, China has already become the world's first major electrified nation, rapidly reducing its dependence on fossil fuels. China's advantages in this area will gradually become more apparent over the next decade.